Alright, we're looking at inequalities and how we're going to be solving and graphing inequalities. Okay, an inequality is just what it says. Inequality means not equal. Two things that are not equal. Normally we said x equals 4, that was an equation, something that was equal. In this case, we have these less than or greater than symbols. So x is bigger than 4, and what we said before is we want you to try to graph these on a number line. Okay, we would just plot 4 on the number line. I should plot 0 as well probably. So 1, 2, 3, 4. And what I'm going to do is I need to say, well, at 4, I'm going to say, here's 4, and I want to have everything bigger than 4. So I'm shading to the right. Usually this arrow is going to help distinguish you in what direction you should be going. In the second one, x is less than or equal to 17. So like in zeros here, 17 would be way off there. For this one, I would be shading to the left because I want numbers less than 17. Now, because it's less than or equal to, the rule is that I need a filled in circle. So again, just as a reminder, equal sign means filled in. The just greater than or less than without the equal sign means that it's open. We don't include 4. In this case, we do include 17. Okay, now what we're going to find out is that we can solve equations, or inequalities, the exact same way that we solve the equations. So inequalities work the same way. I would subtract 5 from both sides, leaving you with 2x is bigger than negative 4. Divide both sides by 2, and be left with x is bigger than negative 2. And I would graph it, guess what, the exact same way. I have a 0, I have a negative 2, and I want, because it's greater than, I want an open circle and shading off to the right-hand side for that. So all numbers bigger than negative 2. Alright, so here's a couple things that we need to look at that might make things a little more tricky. In this first one, 40 is bigger than x. Notice that the x is on the right instead of on the left, like in the previous problem. What I like to do is to try to flip this around, make it something easier. Well, if I flip the inequality around, putting x first, that means I need to switch this sign around. X is less than 40. Notice the arrow is still pointing at the x. The inequality symbol is still pointing at the x. Okay, and of course we can graph this. I think we're good at graphing. Here's 40, open circle to the left. Now you can also read this from right to left. 40 is greater than x, or right to left, x is less than 40. And that's exactly how we wrote it when we rewrote. Okay, in this second one here, same thing. We're going to subtract 5 from both sides because I need to get this negative 2x by itself. When I do that, it leaves me negative 2x is bigger than or equal to positive 8. I'll then divide both sides by negative 2 and gives me x is bigger than or equal to negative 4. Now, here's the big trick. Anytime, any time that you divide by a negative number, don't forget that this sign right here needs to flip-flop. So, where it was a greater than or equal to, I need to switch that to be less than or equal to. That only happens when I divide by a negative number. Not if I get a negative number. So like in this last problem, I got a negative answer, but I didn't switch the sign. It's only when this number down here ends up being a negative value. Okay, so again, you should know how to graph that. There's negative 4 compared to 0. Filled in because it's greater than or less than or equal to. Arrows teaching me which way to go. Okay, these two on the bottom. Same thing. Now what's going to happen here, you have 2x. It's a negative 2x. Make sure you keep all that together. We need to get rid of the 12. It's a positive 12, so I need to subtract 12 from both sides. So negative 8 is less than negative 2x. Divide by negative 2 on both sides. I'm dividing by negative, so I do need to switch my sign. X will be less than 4. 4 is greater than x. If you prefer, rewrite it the other direction. X is less than 4. So again, here's your 4. I'll be going open and going to the left. Okay, and this last one. Anytime you have a fraction, something on the bottom, what I'm going to first do is get rid of that fraction by multiplying both sides by that number. Because if I times 7, divide by 7, it'll cancel, leaving me 21 here. And the numerator just stays the same, 5 minus 4x. And I can solve that just like I've been solving all these problems. I'll subtract 5, leaving me negative 4x less than or equal to 16. I'll divide by -4. Notice it's a -4 I'm dividing by, so I'll switch the sign, and I'll get x is greater than -4. So there's -4, filled in because it's greater than or equal to, and shading off to the right. There you have it, your intro to inequalities, and much more are coming your way.